Hi, my name's Ella, and today I'm going to talk to you a little bit about the science of sound. Have you ever wondered why a cowboy's whip makes a cracking noise, or why lightning makes thunder? Well, let's find out. Now, on first impressions, you might think that I'm just a scientist who works in a lab all day, but actually I have a really interesting hobby that involves making loads of noise. I play Brazilian samba drums. Sound comes from vibrations. The vibrations begin with a mechanical movement, such as a drumstick hitting a drum or a ball hitting a wall. The movement causes the tiny particles in the air around that point to vibrate, and they in turn bump into the particles around them, causing them to vibrate too. This continues from one particle to the next, rather like dominoes falling, causing the sound to travel and creating sound waves. When we talk about the pitch of a note, we're actually talking about the frequency of the sound wave, which is measured in units called hertz. So, how do we sense and process these sound waves? Well, that's a job for our ears. The ear is an extremely clever organ that is made up of a collection of tiny bones, tubes and membranes which process the sound and send it to the brain. The funnel-like shape of the ear is effective at collecting the sound wave and filtering it through the ear passage, where it makes the eardrum vibrate. This signal is gradually converted into an electrical signal by the rest of the ear, and this is then sent to the brain. Sound is extremely important in other species around the world, not just humans. Do you remember earlier when I spoke about the frequency of sound being measured in units called hertz? Well, a human being can hear up to around 20,000 hertz, and that is the highest of high pitches that you can imagine. But a dolphin, for example, can hear up to 100,000 hertz. That's 5 times as much as humans. Actually, in the wild, many animals rely on sound because it enables them to detect danger approaching. They also very often have larger ears than humans compared to their body size. Imagine the ears of an elephant and how much more sound that could catch than humans, or the ears of a mouse, which compared to the rest of its body are huge. In dry air, sound travels at 343 metres per second. That's 768 miles per hour. To put that in terms that you can understand, imagine the length of a football pitch. If you were to run at the same speed as sound, you would have to run up and down that football pitch 10 times in about 3 seconds. That's incredibly fast. On top of this, when sound travels through water, it travels 4 times faster than it does through air, and through steel it's 13 times faster. So next let's take a look at this short video clip. Why the whip in the video makes that cracking noise is because it's actually travelling faster than the speed of sound. When a lightning bolt travels from the cloud to the ground, it actually opens up a little hole in the air called a channel. Once the light is gone, the air floods back into the channel and creates a sound wave that we hear as thunder. If we are watching the sky, we see the lightning before we hear the thunder. That is because light travels much faster than sound waves. We can estimate the distance of lightning by counting how many seconds it takes until we hear the thunder. It takes approximately 5 seconds for the sound to travel 1 mile. If the thunder follows the lightning almost instantly, you know the lightning is too close for comfort. I hope you've enjoyed the video. Thanks a lot for watching. Bye!